All right, so this section is going to cover the law of cosines. All right, so let's review a little bit with the law of sines. Now, if you are given this angle is, for example, 35 degrees here, and this side has a length of 9, and this side over here has a length of 10, and I want to know what is the measure of this angle. Well, I can find that measure by using your law of sines, which would be sine of 35 over 9 equals the sine of x over 10. And you only have one unknown value in that proportion, so you can solve for x. And once you know x, you can get the other angle here, and then you can do law of sines again to get this opposite side. Now, what happens if instead of knowing this side is 9, we know this side is 9? And I want to find, for example, this side over here. Well, in this situation, you're not going to be able to use law of sines because you would have sine of 35 over x equals the sine of some unknown angle, and we might call this angle y, would be sine of angle y over 10. Well, the problem here is we have two unknowns, which means you cannot solve for x or y in this situation. So the law of sines can be used to solve triangles in some situations. In all other situations, when it cannot be used, such as this, you are going to be using what is called the law of cosines. Now, this is your formula for law of cosines. You have a squared equals b squared plus c squared minus 2 times b times c times the cosine of angle A. Now, one of the important things to recognize in this is the relationship between this angle and this side. All right, so the angle that you are using is going to be opposite of this side. And so these two things, your bookends, if you will, have to be opposite of each other. So if you have this angle given to you, your formula is going to start with the side opposite that angle. Or if you are given this side and you're looking for this angle, you're going to start with the side opposite the angle you're looking for. So in the situation that we have right here, let's go ahead and work this out. Now, the law of cosines is going to be used whenever you have a side angle side situation or a side situation, which means side angle side, you know two sides and you know the angle in between those two sides. So you have two sides and the angle in between. Or if you know all the sides but none of the angles, you can also use the law of cosines. Well, the situation we have here, we have a side angle side, so we're going to set up law of cosines. The angle given to us is 34 degrees. So that is the angle that we're going to take the cosine of, which means our formula will start with the side opposite, which is x. All right, so you're going to have x squared equals, and then the other two sides squared and added together, minus 2 times those two sides, times the cosine of angle 34 degrees. All right, so if we are solving for x, we are simply going to be taking the square root of all of that stuff right here. So when you take the square root of all this, you are going to end up with x is equal to 7.5. Now, if x is 7.5, we can now go to our law of sines, where the sine of sine of angle F over 13 would equal the sine of 34 over that 7.5 that we just found. And if you cross multiply and then find the inverse, so cross multiplying, you're going to get 7.5 times the sine of angle F equals 13 times the sine of 34, which means F is equal to the sine inverse of 13 sine of 34 divided by 7.5. So you had to divide 7.5 to the other side first, and then move the sign over, making it sine inverse. All right, so this comes out to then 75.8 degrees for angle F. Now, 75.8 degrees is an acute angle. And if we look at angle F up here, this is not an acute angle. This is an obtuse angle. All right, so what that means is that this is going to actually be one of those ambiguous case situations where two triangles could actually be formed from the information given to us. One of those triangles would be an acute triangle, and the other triangle would be an obtuse triangle. Now, the angle given to us here is an acute angle, but F is an obtuse angle. These actually form a linear pair, which means angle F would be 180 degrees minus the 75.8, which means angle F will come out to 104.2 degrees. Again, that's 180 minus 75.8. And then you can add the 34 and the 104.2 together. Subtracting from 180 will give you 41.8 degrees for the measure of angle G. All right, so the next problem we have here is going to be a side-side situation. And on our formula, if we have a side-side-side situation, we can start with any angle that we want to find. So it doesn't really matter which one we start with. Let's go ahead and say we're going to start with finding the measure of angle A. So if we're going to find the measure of angle A, that means we are going to start the formula with 9 squared. And that would equal 11 squared plus 14 squared minus 2 times 11 times 14 times the cosine of angle A. All right, so if you take 9 squared and subtract 11 squared and subtract the 14 squared, that will give you negative 236. 2 times 11 times 14 is negative 308 times the cosine of angle A. If you divide the negative 308 to the other side, that's going to give us the cosine of angle A is equal to 236 over 308. Negative divided by negative is positive, giving us angle A is equal to the cosine inverse of that ratio. and that gives us angle A has a measure of 40.0 degrees. All right, so now we can set up law of sines to find the next angle. So let's go ahead and find angle B. Law of sines would be sine of angle B over 11 equals the sine of the 40 degrees that we just found over the side opposite that, which was 9. So then if we cross multiply, that will give us 9 times the sine of angle B equals 11 times the sine of 40. If you divide by 9 and then take the sine inverse, that is going to come out to 51.8 degrees. And that looks reasonable for measure of angle B. So we do have 51.8 degrees here. And then we can get angle C by adding these together and subtracting from 180, and that would come up with 88.2 degrees. All right, so what I want you to do is take a few minutes, pause this video, write the problem down, and then solve this triangle, find the measures of angles A, B, and C. So go ahead and pause the video, solve this, and then unpause it and reveal the solution here. All right, welcome back. So the first thing we did is we used law of cosines. I found angle A first, and then I used this value with the law of sines to find angle B, and then I used these two angles to find the measure of angle C. It does not have to be done in this order. It can be done using any order that you want, but the result will still be the same. All right, so we would like to have a formula for being able to find the area of triangles by using only the length of the different sides, the three sides of your triangle. Because to find the height of a triangle, especially if it is a very large triangle like a piece of land or something, it becomes much more difficult to be able to draw a line or to walk a line perpendicular to a side to get an altitude to be able to use your geometry formula. And it's also difficult sometimes to get the measure of an angle unless you have special instruments for being able to find or calculate those angle measurements. So if we have just the length of the sides of a triangle, you could just use a tape measure or a ruler or some kind of instrument for measuring distance, which is much easier to find. You can use that to measure the length of the three sides of your triangle, and we want to come up with an area formula that will utilize those three sides only. All right, so that is where we come in with what is called Heron's formula. Heron's formula is used for finding the area of a triangle when you know three sides of that triangle. And this is the formula right here. A, B, and C are the three sides of your triangle. S stands for the semi-perimeter, and it's located in 4 different places in this formula. Now the semi-perimeter is just simply half of the perimeter. And to get the perimeter, you need to know all three sides. All right, so let's take a look at this problem right here. We need to find the length of the third side, and we can do that using our law of cosines. And so if I put an x here, or actually let me go ahead and use g for this. G squared would equal 4 squared plus 9 squared minus 2 times 4 times 9 times the cosine of 51 degrees. And if you take the square root of all that, you're going to end up with g comes out to approximately 7.2. All right, so that means that your semiperimeter would be 1/2 of the three sides added together. So 1/2 of 4 plus 9 plus 7.2, which means S comes out to 10.1. All right, so now that we have the semiperimeter, we can calculate the area of this triangle real easily just by plugging everything into the Heron's formula. So it's going to be S times S minus A, which is 10.1 times 10.1 minus A, and A can be any one of the triangles, so I'll just use the 4, times S minus B, so 10.1 minus another side, and it doesn't matter which one, times S minus C, which would be 10.1 minus the third side, which is about 7.2. And when you work all this out, this gives us an area that is approximately 14.0 for the area. Now, this particular triangle would actually have been easier to use the other formula that we had, which was area is 1/2 A times B times the sine of angle C, because this formula says two sides and the angle in between them, which is the situation we have here. Now, if we were to figure out 1/2 times 4 times 9 times the sine of angle 51 degrees, that answer will still come out to the same as Heron's formula. This is just another formula. So one of the things with formulas is you want to use the best formula in the right situations. This particular situation would have been better to have used this formula, but I wanted y'all to get some practice with using Heron's formula. Heron's formula is typically used when you know three sides of a triangle. All right, so let's take a look at the last problem here. In this situation, we need to find the length of this third side. Now, we cannot use the 1/2 A times B times the sine of angle C formula, because you need to know two sides and the angle in between those two sides. Well, we do not know this side, and we need this side if we are given this angle in order to use that formula up here. We need an angle and the two sides on each side of it. So if we find this side, then we could use this formula, or we could use Heron's formula. It doesn't really matter which one. I'm just going to find this side, and then we will use Heron's formula on this. All right, so one way that we can do this is we can use law of sines. Let me put some unknown values in here. Let me call this angle X, angle Y, and side Z. All right, so this means the sine of 65 over 13 would equal the sine of angle X over 14, which would give us X is equal to sine inverse of 14 sine 65 over 13, which comes out to 77.4 degrees, because this is an angle. And if I want to know the measure of angle Y, I would take 180 minus that 77.4 and 65 added together, which would give us an angle of 37.6 degrees. All right, well now we can use law of sines one more time and say the sine of 37.6 degrees over side Z equals the sine of 65 over 13. And so Z would equal 13 sine 37.6 divided by sine of 65, which will come out to about 8.7. Now that was kind of a lot of work to be able to get 8.7 out of that. We had to do law of sines twice, and we had to add and subtract from 180 to eventually get the length of that side. Now, another way that we could have done this to find Z is in one step, write out the law of cosines. All right, so the law of cosines would start out as 13 squared equals Z squared plus 14 squared minus 2 times Z times 14 times the cosine of 65 degrees. All right, so let me work this out a little bit here. It's 169. 14 squared is 196. This would be 28Z cosine of 65. Now, one thing to notice is that this is a quadratic equation. We have Z squared, we have Z to the first power, and we have a constant. And we solve quadratics by setting the equation equal to 0. So we're going to do that. This would be Z squared minus 28Z cosine 65 and then plus 27. All right, so normally when you are solving quadratics, at this point we would try to factor this thing, but factoring 28 cosine of 65 is not going to be an easy process. So we need another method of being able to solve this. One thing we could use would be quadratic formula. Again, that would be kind of a tedious effort right there to use quadratic formula with these values. So another method would be to graph this. Now, if you graph this into one equation, what you are looking for then is, if you think of this equation being y equals then what we are looking for is where this equation is equal to 0, which means when y is equal to 0. Well, y is equal to 0 at all the points on the x-axis, which means if we graph this, we are looking for where the graph crosses the x-axis. Well, let's go ahead and take a look at the graph of this. And here it is. On this graph, let me bring this back down here. On this graph, you can see that we have two solutions. One is 3.087 and the other is 8.746. That means there are two possible values for the length of this side, okay, Z. What that means is that we have an ambiguous triangle situation, ambiguous case, because this one will be used when you have an obtuse triangle, which means your triangle would be like this because your 65-degree angle is here, the 13 is over here, and 14 is over here. All right, so if this side right here swings around this direction, you would get your situation with your ambiguous case, because 13 is actually longer than the height but shorter than this side. That creates your ambiguous case. So the other triangle that would be involved here would look kind of like this, where this is your 65 degrees, this side is 14, and this side is 13. Now, with this one, this would have a length of 3.1, that's the one side, and then on the other one, we would have this side as 8.7. Now, this triangle that we are dealing with does not have an obtuse angle, so we are dealing with this side having a length of 8.7. All right, so once we know the length of this side is 8.7, we can then use the length of these three sides to calculate, using Heron's formula, the area of this triangle. All right, so let's go ahead and do this. The semiperimeter would be 1/2 of 13 plus 14 plus 8.7. So S is equal to 17.85. And now if we use Heron's formula, and we had 17.85 times 17.85 minus 13 times 17.85 minus 14 times 17.85 minus 8.7. This will come out to approximately 55.1.